So I've been working on this indoor garden, and it involves quite a bit of plumbing, and I figured it'd be a good opportunity to learn about some electronics. And so what I've got here is I've got just oh shoot, I don't like that. A temporary power supply right here, or right here. I got my Arduino board. It's kind of like a tiny computer that you can program to behave in different ways, and then it'll take output and input through its pinholes over here. I hooked up this float switch right here, so that as the water rises in this one container, this guy will open up. And so it's wired into this relay right here, which is supposed to handle 120 volts. Here, so let's go ahead and plug this guy in, and then into that relay, it's hooked up into the solenoid right here. So we're gonna plug this guy in. You heard a pop, which is that solenoid kicking on. And let's make sure we got power to our Arduino. And then we can kind of flip this guy. Hear that? Then we open it up. So this solenoid right here, he is a normally closed, and so as it's powered, it's opened up. And so whenever this guy has no water, whenever this container that has this guy in it has no water, it is, what would that be? Open. It is opened. And as the water level rises, it is closed. It doesn't make much sense unless I showed you like a diagram of what all the plumbing involves, but it is a cool little setup. One of the issues that was kind of annoying with it was it's not just a single loop. Whenever you're wiring this Arduino in with your switch, you have to have a sort of like a bypass loop, which is why you see that resistor right there. And it makes whenever the switch is closed or open, so there's no connection, it has a bypass through that resistor, and it makes its way all the way back to ground. That's sort of a cool setup that I've had the chance of learning and figuring out. It's like 20 lines of code. It's not a whole lot. There you go.